morning, this is Kasturi Day. Now I'm going to discuss this question answer series of language of chemistry. Okay, so I was discussing in my last video the study questions where we were discussing about the balancing of the equations. Okay, so Mg plus O2 gives us MgO. Okay, but this equation is not balanced. This is a skeletal equation. Okay, so in the reactant side we see Mg is equal to 1, O is equal to 2. Okay, and the product side we see Mg is equal to 1, O is equal to 1. So product side, one oxygen atom is less. So in the product side we multiply the product side by 2. Though it becomes what? 2 MgO, and that means Mg is equal to 2 and O is equal to 1. Now the reactant side here, the Mg has become has less number of atoms. Okay, one atom is less there. So reactant side we multiply Mg with 2. Okay, now the reactant side becomes Mg is equal to 2, O is equal to 2, and in the product side also it is Mg is equal to 2 and O is equal to 2. So the final equation it becomes what? 2 Mg plus O2, and that gives us 2 MgO. That's a balanced equation. Next we come to KClO3, that gives us KCl plus O2. Now see, reactant side K is equal to 1, Cl is equal to 1 and O is equal to 3, and product side K is equal to 1, Cl is equal to 1 and O is equal to 2. Here also see, oxygen atom in the product side is 1 less, 1 atom less. So in the reactant side we first do one thing. See, in the reactant side we multiply it by 2, and that becomes 2 into KClO3. Okay, so reactant side becomes K2Cl2 and O6. So now the product side is O2, and also the K is also 1, Cl is equal to 1 and O is equal to 2. So now what we do, we multiply the product side KCl with 2 and oxygen, that is O2, with 3. Okay, so that becomes what? That the product side K becomes 2, Cl becomes 2 and O becomes 6. See, 3 into 2, that becomes 6. And the reactant side is also K is equal to 2, Cl is equal to 2 and O is equal to 6. So the balance equation, final equation becomes 2ClO3, that will be equal to 2Cl plus 3O2. Next is N2 plus H2, that becomes NH3. Okay, so reactant side N is 2, H is 2, and in product side N is 1 and H is 3. So in the product side NH3 is multiplied by 2, and that becomes N is equal to 2 and H is equal to 6. Now we see on the reactant side H is equal to 2. So to make it 6, we multiply the reactant side hydrogen, that is H2, into 3. So now the reactant side becomes N is equal to 2 and H is equal to 6, and product side N is equal to 2 and H is equal to 6. So final equation it becomes N is equal to 2, 3H plus 3H2, and that becomes 2NH3. Okay. Now H2 plus O2, that gives us H2O. Now reactant side H is equal to 2, O is equal to 2, and product side H is equal to 2, O is equal to 1. So 2 into H2O. That means reactant side hydrogen H is equal to 2, O is equal to 2, and product side, as we have multiplied the product into this H2O into 2, therefore the product side H has become into 4 and O is equal to 2. So now H has become 4 on the product side. Now to make that 4 also in the reactant side, we multiply H2 into 2. Multiply it by 2. Now the reactant side, now it becomes H is equal to 4, O is equal to 2. Product side also H is equal to 4, O is equal to 2. Now so what happens? The equation becomes 2H2 plus O2 gives us 2H2O. Again, Na2O plus H2O, that gives us NaOH. Now reactant side, see, sodium is equal to 2, hydrogen is equal to 2, O is equal to 2. And on the product side, all of them, that is sodium, hydrogen and oxygen, all of them are 1 atoms. Okay, all of them have 1 atoms each. Now, 2, therefore, what we do, we multiply the product is NaOH into 2, multiply it by 2. So, it becomes 2Na, 2H and 2O on the product side, and it is also like that in the reactant side. Reactants, it is also already has become already it's there, that is N is equal to 2, H is equal to 2 and O is equal to 2. Now the equation becomes balanced. So final equation it is that Na2O plus H2O, and that gives us 2NaOH. That's a balanced equation. Okay. Again, CO plus O2 gives us CO2. See, reactant side C is equal to 1, O is equal to 3, and product side C is equal to 1, O is equal to 2. So, 2, we multiply the reactant side carbon monoxide, that is CO, by 2. So, it becomes reactant side C is equal to 2, O is equal to 4. But in the product side C is equal to 1 and O is 2. So now we multiply the product side, that is CO2, with 2. Okay, and so what become the product side, it becomes now that C is equal to 2 and O is equal to 4. Okay, therefore the reactant side is C is equal to 2, O is equal to 4, and product side is also C is equal to 2 and O is equal to 4. That's for the balanced equation. Now it becomes, final equation becomes 2CO plus O2 gives us 2CO2. Now again, zinc Zn plus HCl becomes ZnCl2 plus H2. See, on the reactant side, Zn is equal to 1, H is equal to 1, Cl is equal to 1. But on the product side, Zn is equal to 1, Cl is equal to 2 and H is equal to 2. Therefore, what we do on the reactant side, we multiply the HCl compound, 1 atom of HCl, by 2. And so it becomes, on the reactant side, Zn is equal to 1, H is equal to 2 and Cl is equal to 2. And the product side, it's already there, that is Zn is equal to 1, H is equal to 2 and Cl is equal to 2. Therefore, the final equation, it becomes what? Zn plus 2HCl, that gives us ZnCl2 plus H2, and that's a final balanced equation. Now, what information is conveyed by the balanced equation? Okay, why we balance the equation? It tells us about what are the reactants which are taking part in the equation. It takes us about the product which are formed in the equation, formed in the reaction, and it also tells the number of molecules of each reactant which are taking part in the reaction. It also tells why the number of what the number of atoms or number of molecules which are produced after the reaction. It also tells us the relative mass of the reactants which are taking part in the chemical reaction and the products formed. Okay, it tells us what is the relative mass of the reactants, relative mass of the reactants, also the relative mass of the products, okay, in the chemical reaction. Okay, so that's why that is the information which is conveyed by a balanced equation. Now, what is a catalyst? Catalyst is a substance that changes the rate of the chemical reaction but itself does not take part in the reaction. Okay, now describe use of a catalyst in a chemical reaction with a suitable example. See, if suitable examples is here, we have used like 2KClO3, potassium chlorate. When we give heat in the presence of manganese dioxide, then this KClO3, that is potassium chlorate, decomposes into potassium chloride and oxygen. Okay, so the potassium chlorate, 4 parts of potassium chlorate and 1 part of manganese dioxide, if we heat them, then it liberates oxygen at a much lower temperature, okay, than if we have not used the MnO2, it would have taken a larger temperature. This higher temperature would have been used for decomposition of this KClO3. And also the reaction becomes fast by adding this MnO2, manganese dioxide. That manganese dioxide is a positive catalyst because it increases the rate of the reaction. Okay. Now, write the chemical formula of the following compounds. Aluminium oxide, Al2O3. calcium sulfate CaSO4, potassium chloride KCl, ammonium hydroxide NH4OH. Okay. Now define radical, valency and molecular formula. See, one thing I want to tell you, that aluminium oxide, see the symbol of aluminium is Al and oxygen is O. Aluminium has a valency 3 and oxygen has a valency 2. Exchanging their valencies, it becomes Al2O3. Okay. Then calcium sulfate also. Calcium Ca is the symbol and sulfate radical symbol is SO4. Okay, but both of them have the same valency, so the valencies get cancelled, and therefore what happens, we write only CaSO4. Like that, potassium chloride KCl, K is potassium, Cl is chlorine, both of them having the same valencies, so say for valencies cancels, and therefore we write as KCl. Aluminium hydroxide, this is also ammonium hydroxide. Ammonium radical is NH4 and OH is for hydroxide, and both of them having the same valencies, and so therefore their valencies get cancelled, and therefore we write NH4OH. Okay. Now we come to the next question, that is define radical, valency and molecular formula. Now radical is an atom or a group of atoms of the same or different elements. Okay, they can be single atom or a group of atoms. They can be of the same element or of different element, but that behave as a single unit. Okay, and have a positive or a negative charge. For example, see ammonium radical. Two elements are there, nitrogen and hydrogen, both of them acting as a single unit having a positive charge. Okay, so this is a radical NH4 plus, single valency, therefore it acts as a single unit. Okay, having one positive, one plus charge, one plus. Okay. Then valency, it is the combining capacity of an atom or a radical with the atoms of the same or other elements. Okay. Then the molecular formula, it is a symbolic representation of one molecule of a compound which shows the number of atoms of each element present in it. Okay, it's a symbolic representation of one molecule of a compound. Okay, and it shows the number of atoms of each element which is present in it. Okay, so another question, there's a time when I can discuss with you. Give the symbols and valencies of the following radicals. Hydroxide, OH, valency is 1. Chloride, Cl, valency 1. Carbonate, CO3, valency 2. Ammonium, NH4, valency 1. Nitrate, NO3, valency 1. Okay, so let me stop here. I'll continue with the rest of the question answers in my next video. Please go through this. If you have any doubt, please do write in the comment box, share with your friends and press the like button, and do also subscribe so they get the notification of my next video, and also it will give me some encouragement so that I can produce you some more good videos for you, interesting videos that can help you in your studies much better. Okay, thank you for watching and have a good day.